Hello, my name is Bruce Doctor, and I teach the surveying lab, which I'd like to give you a tour of at this time. The room itself is rather small, so we only let a few students in at a time, usually the size of a crew. But this is where we keep all of our items, all our equipment, and this is our staging area before they go outside. Normally there's, of course, no real safety concerns for the surveying, other than I make sure that the students are properly dressed for it under the weather conditions. And we have got several different types of exercises that we do, and these are the three main pieces of equipment that we do for that. I also want to point out that I always accompany the students when they're going outside, and I usually have an assistant with me as well. So they always have somebody around them in event of any kind of an emergency that maybe require some kind of first aid treatment. One of the pieces of equipment that we use most frequently is our total station for measuring angles and distances. When we go outside, we have predetermined traverses with designated nail points in the ground for each of the groups. And I can have anywhere from 2 to 3 groups per section. And what they'll do is I'll have them measure their internal angles and all the points within their traverse. And I also have them shoot distances between the points. All of these measurements are taken in 6 times and find equal averages. When I'm done with the internal angles and the distances, I have them also fill out a traverse balance sheet, in which case we will balance out their angles and make adjustments to them. For each station will have at least one, sometimes a couple of prisms with, so we can shoot our distances. I have the students record all of their data in a field book that I provide for them at no cost, and I explain to them the importance of how to fill it out properly, starting with the table of contents and all the procedures. And I explain to them that the idea behind having an efficient field book is that in the event that your company or your firm asks somebody else to go out and reproduce some of your data, I have questions, that somebody who's never been with you before can go out and follow your notes and know exactly the process and procedure you went through to determine it. So we use the total station for doing the traverse work, and we also use it to doing our vertical curves as well, our horizontal curves as well, where we bring the students outside in the quad area on campus, and they'll actually plot out and stake out a horizontal curve. And then they'll take subsequent measurements of their M's and E values and long chord distances and see how their results in the field matched up with the preliminary results by their design. Another piece of equipment that we use quite a bit is the level. Well, we use the level for determining the elevation points on all of their points on their traverse. We also use it to shoot elevation distances for their horizontal curve. They also do a design for a horizontal curve, on a vertical curve, and they also do a preliminary calculation on a vertical curve. They'll take elevations and they'll map out the vertical curve. And what we use for elevation readings is a leveling rod, an old-fashioned leveling rod. I have a couple of these available for each of the student groups, and that's how they'll collect their data for both the vertical curve and also for the leveling. And then the final piece of equipment that we use is the GPS system. This is from Topcon Corporation. This is our base unit, and then my rover unit is here. It's a Tesla computer system that they use, and what I will usually do is have them go out and go back to their traverse points and shoot all of their readings on their points, and then I'll have them look through the data on here and number one, show them how much easier it is to get their data using a GPS versus a total station, and then I'll have them compare that to the results, and then I'll also use the raw data here and make a tin plate file and actually call it into a Civil 3D program just to show how that process can be done and what they're currently using in the field for surveying company. That's would conclude my presentation for the Civil Engineering Lab. Thank you very much for all the hard work that you're doing, and if you have any questions at all, please feel free to contact me. Thank you.